going to start using some construction geometry. Part of the thing I'd like to demonstrate with this particular exercise is the use of construction geometry. Now, I'm going to simply make a vertical and a horizontal line from the origin, so one of each. And although we might not actually use these lines, it's a good practice to get into to do this, so that you have lines that you can measure from, you can put dimensions from, you can also use them for mirroring. One of the basic principles is that it makes a lot of sense to have your origin in the center of your part. Okay, now hopefully that'll make a little bit more sense once we start drawing things up. We're going to use the center rectangle tool. So there's a bunch of rectangle options. We want to use the center rectangle. And we're going to start the center on the origin and then just drag our rectangle out. And as you can see, we have a continuous outline, but we also have automatically got two construction lines. Now these construction lines go through the origin, and that's what determines the position of the rectangle, not the size. The size is still flexible, so what we need to do is to put some dimensions on the rectangle. Firstly, we want to have a height of 10 millimeters, and we're going to have a width of 38. Now, if we were just going to extrude that up, we would find that we would have flat sides, and that's not exactly what we want. We want to have some curvature on these sides. So the way we do that is we're going to use a 3-point arc. So starting on one end, we're going to attach the ends of the arc to the corners of the rectangle, and I'm going to put a dimension on that arc of 100, radius of 100. Okay. Now the problem is, of course, we now have we don't have a continuous profile the entire way around this part. So this line here wants to be construction geometry. Now there's two ways of turning this into construction geometry. Either we can go to this little icon up here, or we can go across to the dialog box over here and click for construction. Okay. Now we also want to have this line the same, so we're going to just turn that into construction geometry, because what we're going to do next is to mirror that curve across to the other side. So what I do is I select the curve and I select this horizontal line. So this is why we've created this horizontal construction line, so that it makes it easier for us to mirror things. So that's the sketch. That's the completed sketch. What we have here is 4 lines of entities that we're going to use to create the 3D extrusion, and we have a whole bunch of construction lines. This is actually this is a good example of how to construct a robust sketch. Use as many construction lines as you think is necessary, and it should make your life easier. So what we're going to do next is we're going to extrude this out. So just a very simple boss extrude. We're going to use a blind extrude, and we're going to extrude that up 38. So now you can see we've got that, it's almost a rectangle but with curved sides. Okay, what we're going to do next is to create a chamfer on the top edges of the padlock body. To make our life a little bit easier, I'm going to firstly highlight or show some of two of the planes. Now the way of doing that is right-clicking on the plane you want to see, and just going to this little glasses symbol here, which is to show, and we want to do the same thing with the right plane. So right-click and go to show. Now we could use, there is a chamfer command. We could just select that edge and then go to chamfer, but that would create a chamfer which is even the entire length of the edge. What we want is a chamfer which is bigger in the middle and tapers to nothing on the ends. Okay, and plus it adds a little bit of complexity to the construction. So what we're going to do is select the right plane. We're going to create a sketch on the right plane. Now we want a little triangular sketch that's just in this corner. And what we're going to do is we're going to use some of the existing 3D geometry and convert that into sketch elements. So the first thing we're going to do is use a what they call a silhouette edge. Now if you roll your cursor to the middle of this curved face, you'll find this little symbol, which is a little barrel, a little yellow barrel with a green line down the middle. That designates the silhouette edge. Just click on that, and then you go to convert entities up the top here, and that will convert that into a sketch entity. Now that happens to be coincident with the right plane anyway, so that's in exactly the right spot. What we want to do next though is we need a horizontal line. Now, and it wants to be exactly the length so that it matches up with the ends here. So the easy way of doing that is just to select this bit of this edge here on the 3D geometry, select that, go to convert entities, and you'll see what that has done. It's converted this curved edge, which is a three-dimensional edge, and it's projected it onto the right plane. And all that we've got left is that basically that projection, that little line there on the right plane, is the projection of that curved line onto the right plane. Okay. Next thing we're going to do is just finish off the triangle by using a normal line, and I'm going to just drag that over here somewhere. I don't really know where it needs to be right yet, so I'm going to do that, and then I'm going to trim it back to this vertical line. So I'm going to trim that, and I'm also going to trim this line. So now I have that triangle. Now the one thing I know about this triangle is that I want it to be 45 degrees because I want to have an almost symmetrical sort of a cut. So I'm going to select the dimension tool, I'm going to click on the horizontal, and then I'm going to come down to the diagonal line and drag the dimension out here. Now it's 49 degrees, I'm going to make that 45, and that's the triangle that we're going to use to cut the chamfer. Okay, so what I'm going to do next is go to CUT EXTRUDE. Now by default it's a blind cut extrude. What I'd like to do is to do a through all, because I'm not worried about how large this is, so I want to cut through all. Now that's only going in one direction. We have the option of going down here to direction 2 and also doing a through all. We could do a blind or whatever, but by default, because direction 1 is through all, direction 2 becomes through all. So hit OK, and there we have this chamfer, which is, as you see, it tapers away to nothing, and it's just the right size. Okay, now we could go and repeat the whole process on the other side, but an easier way to do that is to mirror this cut extrude over to the other side. So there are two ways of doing this. We can select the cut extrude here, control select the front plane, or we can do it straight from the model. We can click on that face, which is created by the cut extrude, and holding the control key down, we can also click on the front plane. We then go up here to the mirror feature and select that, and we seem to have lost our feature to mirror. That's it, cut extrude, so I've just reselected it and hit OK, and what it's done is mirrored that cut extrude feature across to the other side. What we're going to do next is we're going to create the holes that locate the shackle of the padlock. Now so far we've drawn our two sketches on onto planes. What we're going to do next though is draw a sketch on a face. So in exactly the same way as selecting a plane to create a sketch on, we can then select a face and then create a sketch on that face. Now these holes are going to be just circular holes bored into the padlock body. So we're just going to use a circle command. We're going to use the center circle without much concern about where it's placed or how big it is, which is a typical process in SolidWorks. I'm going to exit out of the circle drawing menu. Now this circle is not in the right spot, so and it's not the right size, so I need to position it and dimension it. So what I'm going to do is I'm going to use the center line. So I'm going to create some construction geometry. And I'm going to draw that construction geometry from the origin. I'm just going to drag that to the center of the circle. Okay. Now, as you can see, the circle is slightly off center. We want to have that straight. The easy way of doing it is to draw that bit of construction line. Now, then go over to where it says Add Relations, click Horizontal, and what it'll do is we'll snap that construction line to the horizontal, and that will drag the circle with it. So now we have a circle that is constrained to that center line. The size is still flexible and the position away from the center is still flexible, but it's constrained to the center line. So what we do next is put a dimension on that bit of construction line as well. So if I make that 12 millimeters, what that will do is also move the circle so that the center of the circle is 12 millimeters away from the origin. And the final thing I'm going to do is to put a diameter on that circle. Let's call that 8 millimeters. And so then I have a circle which is exactly where I want it to be. I could have started off by drawing a horizontal construction line on the sketch, as we did in the first sketch, which would have meant that would have made that a little bit easier. So what I'm going to do next is create another bit of construction geometry. This time I'm going to drag that down vertically, and we're going to use that bit of that construction line to mirror this circle around. So we control select the vertical center line and the circle, and we go up here to mirror entities, and now we have a mirrored circle on the other side. And then we can very simply use that to create a cut extrude, and we're going to extrude that down by 10 millimeters. So that's a blind cut extrude of 10 millimeters. And there we have the holes for the shackle. The next step is to create the shackle for the padlock. Now the way I'm going to do that is I'm going to start by creating a sketch on this top face again. So go to create sketch. Now the shackle needs to be slightly smaller than the holes. Generally this sort of thing needs a bit of a clearance. So what I'm going to do is I'm going to use the edge of this hole to construct our geometry. Now we've used the convert entities command in the past. What we're going to use is offset entities, which is similar, but obviously it doesn't convert entities in exactly the same spot, just offsets them slightly either smaller or larger. Now we want to make this 0.5 of a millimeter smaller, so the offset entities, type in 0.5. Now that will make it 0.5 bigger. We want it to be 0.5 smaller, so press the reverse, tick the reverse box there, and we'll have a sketch which is half a millimeter smaller. Now with that sketch we're going to do an extrusion, so we'll go to the extruded boss base, and we want to extrude that in two directions. Firstly, we want to extrude it in an upward direction, which we're going to make 20 millimeters. Now at the moment that will just be sitting in space, not actually connected to the body. What we want to do is to extrude it in the other direction as well, down to the body. Now we could just select a 10 millimeter blind extrusion because we know that hole is 10 millimeters deep, but we also have the option of extruding up to next, which in this case does exactly the same thing, but it's a better option to go up to next, because it means if we change the depth of that hole, we don't have to change the length of that boss extrusion. So hit OK, and there we have the start of our shackle. Right, the next stage is to make the curved section of the shackle, and in order to do that, what we're going to do is we're going to create a sketch on the face, on the top of that cylinder. So go to sketch, create a sketch there. And again, this time we're just going to convert entities. So in the past, there are two ways to do this. We want a circle which is exactly the same size as that top face. We could just draw a circle there and dimension it up and try and get it in the right spot. But a much easier way is to use convert entities. And we can do two things. We can either select the edge and then go convert entities, or we can select the face, which is slightly easier, and then go and convert entities. And what it will do is it will convert all the edges around that face. In this case it's a circle, so it's quite simple, but if that was a more complex face, that would be easier than selecting each edge on a complex face. Okay, so what we're going to do with this sketch is we're going to use it to create a boss revolve. Now, with a boss revolve, we need to have some sketch elements to revolve, but we also need to have some construction geometry or a center line to revolve around. So if we go to center line, I want to revolve that around the origin. And again, this is one of the great reasons for putting origins in the center of your part. It makes life a lot easier for you. So, okay, we just drag that out at 90 degrees to the front plane. That's the direction we want to revolve it around. And now we can go to boss revolve. We've got revolve cut here, revolve boss base is here, and by default it will revolve it through 360 degrees, which we don't want. We only want that to be revolved through 180 degrees. So just type in 180, and what it's done by default is to revolve it the wrong way around. So we can reverse the direction by clicking on that button, and then we have what we want. So that's the top of our clasp, and the last thing we're going to do is to do something very, very similar. Create another sketch on this plane here, and we're going to convert entities again. So a very simple process of just using the existing faces to convert entities, and then we go to extruded boss base, and we can extrude this up. So this time we're just going to extrude it 10 millimeters because we're going to have an open padlock, and there you have it. The final feature we're going to create is some text which will be embossed on the face of the body. The way we do this is we're going to select the front plane and create a sketch on that plane. We can then create some, using this text tool, click on that. We can then type in what we want. I'm going to call this Tim's padlock. And if we click in the body here, you can see this text moves around depending on where we click. So that's one way to position the text. There are other ways as well. If we were to have a curve, for example, we could attach that text to a curve, but I'm just going to keep it simple for now and hit OK. With this sketch, now that it's got some text in it, we can simply extrude that out. But what we can do, if we were just to extrude that using a blind extrusion, we would find that, let's just see if we can demonstrate this. We'd find that some of the text would come through and some wouldn't, or it would be an uneven height. So what we can do is, if I just go and edit that, instead of doing a blind extrusion, we can do an offset from surface. So we select offset from surface. We'll need a surface to offset it from, and that's the one we're interested in. And I'm going to have a 0.5 of a millimeter offset. Now, if that doesn't work exactly the way you want, you might have to reverse the offset. So as you can see, we want to have that reverse offset, and again we can reverse the direction, but in this case that's the correct direction. So hit OK, and now we have the words Tim's Padlock embossed on the front of the padlock. Of course, you can put your name on there, you can put anything you want, any sort of text. You can also put graphics as well, if you had a logo or whatever. And now the final thing we're going to do is we're going to change the material of the padlock. So if we right click on the material and go to, we have a bunch of materials which are here by default, and in this case brass is there, otherwise we can go to edit material and we can search for it. So I'm just going to select brass and go with that. So we've now changed the material to brass, but not all of the padlock is brass. The shackle is probably chrome plated steel, so what we want to do is to change the appearance back to that. So what we're going to do is select the features that create the shackle, and if you right click on that and go to appearance, you can then select these. You can select a variety of options. You can select the entire part, you can select the particular body, which in this case is the same thing, or we can select just that feature. So if we select the feature, on the right hand side we have a whole bunch of features that we can select, plastic, metal. If we scroll down and find chrome, we can then select chrome plate, and then those features become chrome plate. Now the representation here is just basically a grey colour, but if we do a rendered image, then that will become a lot closer to chrome. Now the final thing is I just want to show you why we've created the shackle in this way, because if we want to change whether this is open or closed, all we have to do is just modify this dimension. So if we were to reduce that dimension, then the whole shackle will close. We can do that in two ways. We can either just click on the part like this and then edit the dimension, or we can right click on the feature and edit that feature. One of the really powerful things about SOLIDWORKS is that all features can always be edited after they've been created, which makes it a very powerful thing. If you don't get things right the first time and you want to make some changes, it's generally a matter of just going back to the feature and making those changes. So let's put that at 15 and see what that looks like. It's not quite closed. Let's try it the other way. Let's go down to 10. It should definitely be closed. There's the closed padlock. And there you have it.